My name is Richard McKee. I'm a student at North Carolina Agricultural and Technical State University in Greensboro, North Carolina. And today I'll be presenting for CSE 805 about a liver disorder dataset using machine learning techniques. First of all, a little bit about the dataset. It's a multivariate dataset, meaning that each instance has several different features. These features are these blood tests that test for liver disorders. The various features have different data types, including integers and categorical and real data types. And the dependent variable is the number of half-pint equivalent alcoholic drinks that the patient drinks per day. And it's self-reported, and so there's a difficulty in assessing the accuracy of self-reported data. And the independent variables are all the blood tests that are administered by doctors at hospitals. And the different test scores that were used are sensitive to liver disorders that are typical indicators of drinking too much. And the table here on the right shows the various scores and their normal ranges. And for drinks per day, it's excessive. It is any drinks 3 or more each day. And now the data set, taking a look at the descriptive statistics, which gives you the mean, standard deviation, the mins, the max. We can see that from the averages, if you compare them to the previous slides values, they're all relatively within range, but on the high end. This data set did not have any missing numbers. There were outliers, but no missing numbers to remove. And now for the data visualization, density plots, which you see here on the right, give you an idea of if there's outliers. The long tails will indicate outliers, or you can tell if data is skewed or not. Box and whisker plots make it easy to see outliers. Bar graphs give you an idea if attributes have a normal or logarithmic distribution. And a correlation matrix shows how closely correlated each features are with each other. And the Box-Cox normalization allows you to see how independent variables are distributed. And here on the box and whisker plot, these circles indicate the outliers, and the extreme outliers should be removed. It's okay to have some that are kind of close to those lines. And yeah, this gives you an idea of where the mean is and how many outliers there are within each feature. This correlation matrix shows different colors and different values. The higher the number, the darker the color, the stronger correlation there is between the two features. And for feature selection, this is important because you want to know which features work best for predicting the outcome. And the extra trees classifier is a learning method that adds randomness to the trees, and thus allows for faster training times. And also it lowers the variance, but it does increase the bias. And the chi-squared method are variables independent of each other. Removing unwanted data and attributes allows faster and more accurate results. It reduces overfitting, and there's a clearer feature importance. And with the feature importance, they're given scores. As you can see, on the plot on the right, the MCV column stands out. And so once it's removed, you can see the other two columns, the sgot and the alkphos tests, have kind of dominated the bar graph areas. And now this proves that the top two most important features are the alkaline phosphate test and the sgot. And now the original data set, before removing any data or anything, the accuracy was only 33%. But after removing the duplicate data and selecting the top features, the accuracy doubled to 67%. And using different test and training splits yielded different results. Using different algorithms yielded different results. And the LR algorithm, which is the left-right scan, it outperformed most of the others, with the LDA and the K nearest neighbors close behind. And now, after removing the MCV column, the LR and K nearest neighbor algorithm lost a small amount of accuracy, but the CART rhythm, the classification and regression tree, which is a binary tree structure, that algorithm increased in accuracy significantly, from 59% to 69%. The CART algorithm has built-in pruning, which prevents overfitting, and it's also easy to interpret. And now, in conclusion, the accuracy only 67%, 69% for the best accuracy result using different algorithms. It's not so bad considering the size of the data set. If there was a way to increase this size significantly, then the accuracy results could increase significantly. And adding to the research, also the accuracy of self-reported data, it kind of throws a little bit of a wild card in there, because you don't know if someone is reporting all the drinks they have, or if they're just not being truthful about it. Then it can skew the results of the data. But thank you for participating, and any questions you can email me. Thank you.